Alright, so in this video we're going to look at complex rational expressions, how do we simplify complex rational expressions. The word complex referring to compound, or usually we're looking at fractions or rational expressions, fraction within fraction. So that's what it means. It's complex as we have a fraction where the numerator contains sum of fraction or difference fraction in the denominator as well. And usually in math class, in algebra, we don't leave this as how it is. Anytime we see complex fraction, we want to simplify it. So the way we simplify a complex fraction is to use the concept of multiply a fraction by a factor of 1. So that way we're not changing the value of the fraction, but just making it to a more nicer equivalent form. So it has to do with LCD or finding LCD. And the goal is what factor of 1 I want to times it to the numerator and denominator, so that way I can simplify the fraction within. So that's what we're trying to do there. And to do that, we need to find the LCD for the top part and the bottom part, or the numerator fractions and the denominator fraction as well. And then one single LCD that works for both of them. So let's just observe the denominators on the numerator here. So we have a to the third. We have a to the third, and then we have b. That's one of the denominator, and then we have b, right? And then we have a squared, b squared, and then we have b squared, right? So to use an LCM or LCD that will work, that will contain all these denominators factors, or all these denominators will divide into this, okay? We want to pick the smallest, that's what LCD stands for, lowest common denominator. So I'm just going to go ahead and say, okay, well, this LCD will contain factors a and b. Okay, so it's going to be a, and b. Okay, now the question is, what power of a and b? Well, b, we can look at power second, because power second will contain the other value b as well. Okay, and then a, we can look at a to the third, because that will guarantee that all the factor of a is divided. So that's gonna be the LCD. Okay, so we want to times in the numerator and denominator by the a to the third b squared, and a to the third b squared, right? So this factor here is a 1, so we're not changing the value of this fraction. Okay, so that's what we're doing. That we times it by the grand LCD that will guarantee to cancel the numerator and denominators fractions. So let's do this. So if we take this times that and times that, we have 1 plus, no, actually it's not going to be 1, it's going to be b remains, because a cube cancel, plus a cube b over, and then this times that is going to be a on the numerator, and that's about it, b squared cancel out, and then this times that, that's just going to be a cube, and then the b squared cancel out, right? So we can factor this further if we want. Let's see, if we factor the b out, we get 1 plus a to the third, and we factor a down here, so we get a times 1 minus a squared, right? So if we want to, we can even factor this further into 1 plus a times 1 plus a minus, I think it's minus in the middle. This is going to be a sum of q. So 1 minus a plus a squared. So that's, this right here is the sum of q, and then this is the difference of square. So we say a times 1 minus a, 1 plus a. So we have this cancel out. So that would just leave us b times 1 minus a plus a squared over a times 1 minus a, right? So that is as far as we can go for this problem. Okay. In the next example, let's see, how do we find the grand LCD here? So let's list all the LCD again. We got z minus 3, and then we have z squared minus 9, and then z minus 3. Now notice that z squared minus 9 factor into z minus 3 times z plus 3. Okay, so the LCD we're looking at that will contain all of these factors will be, so LCD, we know that it contains a factor of z. We know that it's going to contain the factor of z minus 3 and also z plus 3. So if we do this, we guarantee that each of this denominator will divide with this new LCD, and then when we times it to the numerator denominator, it will cancel out all the fraction. Okay, so let's do that. So times by LCD, so z minus 3, z plus 3 times z minus 3, z plus 3. Okay, so let's go ahead and do this. Okay, this right here times the first term, the z factor is going to cancel out, so we're left with z minus 3 times z plus 3. And this times that's going to give us plus 4 times z plus 3, because z minus 3 cancel out. And down here, that's going to leave us with z squared, because z squared minus 9 here is going to cancel out with that one. Plus the z minus 3 going to cancel out that, which is plus z times z plus 3. So now we multiply and simplify. We get z squared minus 9 minus 4z minus 12 over z squared plus z squared plus 3z equals, okay, let's see, z squared minus 4z minus 21 over 2z squared plus 3z. That's as far as we can go there. So the trickiest part is figure out what is the LCD to use. That's part of the hardest part.